Hello guys, let's discuss the algebra of limits. Algebra of limit means like we have functions, there will be addition, subtraction, multiplication, division. So what will happen, like how to separate or how to use algebraic properties in these limits. Okay, so as you can see, the first one I have mentioned here 5 properties or 5 algebra of limits, basically algebraic limits. So you can say that first is where I have limit x tends to a f of plus minus, like subtraction and addition and subtraction both I have taken in the one case itself. So if the function is given in such a way that I can just separate the function or segregate the function like this way. So limit x tends to a f of x plus minus limit x tends to a g of x is equal to L plus minus m. Okay, the separate limit I have taken for them. Similarly, we have a product, we have division, and we have a scalar multiple. The fourth one is a nothing but scalar multiple, and the fifth one is nothing but a mod. Okay, let's discuss this thing one by one. So the first limit I have the addition and subtraction. Okay, so if I'll take the example for this, will be much better. So if I'll take the example here as my function. Okay, my f plus g. Okay, plus minus we can take both. My function is given as like this, x plus sine x. Okay, so this is my function, and if I'll say that limit x tends to 1, what will happen in this case? Now this is my function of x, so this is equal to, and this is my function given. Okay, so this is my function, so I have taken the function and I am applying the limit here for this function. So what will happen in this? So limit, if I'm applying the limit here, limit x tends to 1, I'm just taking this as example, guys. Okay, so x plus sine x. So what we can do, we can apply these limits as separately. Limit x tends to 1, x plus limit x tends to 1 sine x. Okay, and whatever the answer will come for this, either plus minus, if I've taken plus minus, I can take plus minus also here. So whatever the answer will come, like if I'm getting L here 1 or something, I'll say that's L only. Answer of getting L here, I'm here, so plus minus, so final answer is nothing but plus minus m. Okay, it's kind of just segregated, like separately I'll apply the limit to the different individual functions. So where f is my x and g is my sine x, so I applied the limit for the different functions. Okay, next algebraic identity is product. Again, first I will take my function f of g. Okay, first I'll write my f of function. So f of x, I can say that x, and g of x, I can say that again the same function I'm taking sine x. Now in that case, f of g of x will be nothing but x sine x. Now I'm gonna apply the limit here. Limit x tends to pi. So f of f g into x, which is nothing but I can write as limit x tends to pi, and here x sine x. Okay, the product I'm using. Now product, again in the product also we can segregate this. So limit x tends to pi, and here x, and I can write limit individually for sine x also. Limit x tends to pi and sine x. Now I can apply these limits. If I'll apply the limit here x, so I'll get pi here, and into, if I'll apply if I apply the limit here, I'll get sine of pi. We know sine of pi is nothing but a 0 only, so answer is 0. Okay, but my motive is not to show you the answer, just to show you the operation, how to apply the operation here. Okay, next is, I have next algebra of limits, basically division. Okay, same function I'm gonna take again, same my f of x. Or if you are thinking that YSR is taking time, same function, let me take the different function. I'll take this function as x square, and g of x I'll take as cos x. Okay, now limit f by g, and I'm taking here as x tends to pi, and similarly limit x tends to pi, So f by g is nothing but x square by cos x. So what I can do is I can apply these limits individually to the x square and to cos. Okay, so limit, if I'll apply the limit in the numerator, I'm gonna get as pi square. In denominator, I'm gonna get this as a cos of pi. Cos of pi is nothing but -1, so I'm getting answer as minus pi square. So this is what we have to do. Separately, we have to apply the limits. Okay, clear? Now, next, one more, scalar multiple. What is the meaning of scalar multiple? Means just multiplying any number, okay, with the limit, or is if there already exists multiplication of number. Like I'll say one function as limit x tends to 2 and 5x square. Okay, so what we can do here is simply I can write as 5 and limit x tends to 2 x square. Now I can directly apply the limit 5 and limit 2 square, so 20. I'm getting that. Finish. So like that we have to do for all the algebraic functions. Okay, let's see the next one. Limit, we have mod function. Okay, that will also not change our answer. So if we have some function, okay, let's see sin x. Okay, so limit x tends to pi by 2 and we have mod of sin x. Okay, we can write this as nothing but mod limit. We can take the limit inside the mod and it will not gonna change my answer. Okay, and sin x, this. As you can see that if I'm gonna apply the limit here as limit x tends to pi by 2, if I'll apply the limit here, okay, first I'll apply the left hand side only. So I'll write left hand side. So first I'm doing the left hand side. So we have limit x tends to pi by 2 and mod sin of x. We can write this as nothing but mod sin of pi by 2. Sin pi by 2 is nothing but 1, so answer is 1. Similarly, I'm gonna apply the right hand side. So mod limit x tends to pi by 2 sin of x. Okay, now I will apply the limit inside. So mod sin of pi by 2, sin pi by 2 is nothing but 1, again mod 1 is nothing but 1. So you can see that left hand side is equal to right hand side. Yes, so we can open this thing like this way. Okay, so if I'll take the whole mod or just a function mod, it will not gonna change the answer. You can do by either way. Okay.